Hey everyone, and welcome. Today, we're going to tackle one of the biggest buzzwords out there, machine learning. Seriously, you hear it everywhere, but what does it actually mean? Well, let's dive in and break it down.
So to get our heads around this, let's start with a question you've probably wondered about yourself. You open your music app and boom, it suggests a new song you instantly love. How did it do that? Can a machine really learn your taste in music? The answer to that is basically the whole idea here.
Because at its very core, machine learning is really just about making smart guesses. It's all about teaching a computer to learn from past experiences, from data, so it can make predictions about the future. It's actually not all that different from how you and I learn things every day.
Okay, let's make this super clear with an example. So, this is Paul, and after looking at what he listens to, we can see a pattern. He's a big fan of songs that have a fast tempo and a lot of intensity. That's a simple enough rule, right? If a new song is fast and intense, we can probably guess he's gonna like it.
But what about a song like this? It's got a medium tempo and medium intensity. It's kind of in that gray area. Suddenly, our simple little rule doesn't really help us. So is it a thumbs up or a thumbs down from Paul? This is where things get tricky, and it's exactly where machine learning starts to become really, really useful.
Okay, so we've established that a machine can learn from data. But that brings up probably the most important question of all. How do we know if it's actually learned the right thing? How do we grade its homework?
Well, first, the machine needs something to study. We call this training data. So let's imagine a kind of weird scenario where we've collected data on a bunch of runners, specifically how many yams they eat and how fast they can run. This set of information is what we'll use to train our machine learning model.
Now, looking at our yam and running data, we could come up with a couple of different ways to explain it. On the left, you've got this simple black line. It kind of captures the general idea. The more yams you eat, the faster you run. But on the right, you have this crazy green squiggle that hits every single one of our data points perfectly. Now, at first glance, that green squiggle looks way better, doesn't it? I mean, it's a perfect fit.
But here's the twist, and this is so important. The real goal isn't to perfectly describe the data we already have. The goal is to make good predictions on new data the model has never ever seen before. And to do that, we need something called testing data.
And look what happens when we bring in that new testing data. That simple black line, it actually does a way better job of making predictions. It has a much lower error rate. And that complex green squiggle that looks so perfect before, it turns out it's actually terrible at predicting new results. It has a super high error rate.
And this quote from our source material just nails it. The green squiggle didn't actually learn the trend. It basically just memorized all the little random details in the original data. This is maybe the biggest lesson in machine learning. Being a perfect fit for your training data can be a total trap. How you perform on new, unseen data is the only thing that really matters.
All right, so now that we get the super important idea of testing our models, let's check out the three main ways we can actually teach a machine. You can think of these as three different teaching styles.
First up, we've got something called supervised learning. This is kind of like studying for a test with a stack of flashcards that already have the answers on the back. You give the machine a ton of data where the correct answers are already provided.
Take this for example. We could give a machine a bunch of data about coins. The input, or the feature, is the coin's weight, and the output, or the label, is what currency it is. The machine studies this and learns the relationship, so the next time you give it a new coin, it can predict the currency just based on its weight. It's supervised because it learned from a cheat sheet, basically.
Next up is unsupervised learning. And yeah, you guessed it, it's pretty much the exact opposite. With this one, we give the machine a whole mess of data, but with no labels and no right answers. Its job is to just figure it out, to find any hidden patterns or groups all by itself.
For instance, imagine we dump a bunch of cricket player stats into a machine, how many runs they scored versus how many wickets they took. Without telling it anything about cricket, the machine can plot all that data and discover two totally separate groups. It figures out all on its own that there seems to be two types of players here, which we would call batsmen and bowlers.
And finally, there's reinforcement learning. This one is a lot like teaching your dog to sit. The machine learns by trial and error, and it's guided by feedback. It gets a little treat for doing something right, and, well, nothing if it does something wrong.
Let's just walk through this little loop. The system sees a picture of a dog and it takes a guess. Cat. We give it some feedback. Nope, that's wrong. So the system learns from that mistake and adjusts how it thinks. After doing this over and over, through this constant feedback, it eventually gets it right and can correctly identify the next dog.
So that's all some interesting theory, but why should you care? Well, because this stuff is everywhere. It's running in the background of your life every single day, in ways you probably don't even realize. Seriously, machine learning is the engine behind so much of our modern world. It's helping doctors predict diseases, it's analyzing whether social media posts are positive or negative, it's catching fraud for your bank, and it's even helping companies predict if you're about to cancel your subscription.
Here's an amazing, real-world example. Uber's surge pricing. Ever wonder how that price suddenly spikes? That's a machine learning model going to work. It is constantly looking at live data, how many people need a ride, how many cars are on the road, the weather, traffic, and making a prediction to set that price in real time.
Okay, so we've covered a lot. If you're going to walk away from this explainer with just one thing stuck in your head, what should it be? It always comes back to this one idea. It doesn't matter if your model is a simple line or some ridiculously complicated system. The one and only true test of whether it's any good is how well it performs on new data it's never seen before. That is the absolute gold standard.
And that kind of leaves us with one last big question to think about. We now have this incredibly powerful technology that can learn and make predictions. So the question isn't really if machines can learn anymore. The question is, what should we teach them? What are the most important problems we should point this amazing tool towards? Something to chew on. Thanks for tuning in.